Hazim. Today I'm going to talk about fluid mechanics. Fluid mechanics is a branch of physics concerned with the mechanics of fluids, liquid, gases, and plasma. And the force on them, it has a wide range of disciplines, including mechanical, civil, astrophysics, and biology. It can be divided into fluid static and fluid dynamic. Fluid static is the study of fluid, and branch dynamic is the study of the effect of force and fluid motion. It's a branch of continuum mechanics, a subject which modern matter without using the information that is made out of atoms. That is, modern matter macroscopic viewpoint rather than microscopic fluid mechanics. Especially fluid dynamics is an active field of research. Typically mathematically complex, many problems body of code are solved addressed by different methods, typically using computers.
Hi, I'm Ryan Xavier. I'm going to give you one example of fluid mechanics, which is the brake of a car. When the car brakes, the oil from the reservoir is pushed out into the piston, the main piston, and then the piston will push out the oil into the main pipes, and from the main pipes into the slave pipes, and from the slave pipes into the brakes, where it compresses and stops the car.
So now let's get into the car. I'll show you an example of the brake.
What does that mean for a vehicle? The foot exerts a force on the brake pedal. It sets the brake fluid within the brake master cylinder in motion. The fluid is forced through the connected tubing to the wheel brake cylinder. The exerted force is thus transmitted. This principle remains the same, even if more than one wheel brake cylinder is connected.
How are you doing?
Yes, I'm doing fine, thank you.
This is your meat?
Yeah, I'm just about to eat it. Oh,
How could this happen?
gravity, bro.
Oh, what do you know about gravity?
Gravity is a force that attracts an object to the center of the earth. It is originally discovered by Isaac Newton. Do you know that?
I don't even know about that. What else do you know?
Okay, here's the story. One day, young Isaac Newton was sitting down a tree. It was an apple tree. He was resting there when all of a sudden, an apple fell down on his head. He looked at the apple and said, "Why did this apple hit on my head?" It was then he discovered gravity, the theory of gravity. That is why the standard international unit for gravity is Newton.
Qayyum, can I ask you a question?
Sure, go ahead.
Does the gravity on Earth is the same as the gravity on the Moon?
Seriously, man, how old are you? Of course not, they're not the same, because the sizes and masses are totally different. That's why you see astronauts on the moon floating around. The gravitational force on the moon is 1.62 newtons, or meter per second. And on the other hand, on the Earth, the gravitational force is 9.81 newton, which is around 9 times the gravitational force on the moon.
Oh, that explains everything. Thanks, man.
You realize that a special kind of force, which we now know as gravity, was acting on all of the objects on Earth, pulling them toward it. So we've determined that near the surface of the Earth, where we all are, gravity is the cause that produces the effect of all unsupported objects falling down. When an astronaut ship takes off for the moon and moves away from the Earth, the farther from Earth it goes, the less it feels the pull of Earth's gravity. And as it gets closer to the moon, the spaceship begins to feel the tug of the moon's gravity more.
Hi, my name is Bazar.
And my name is Muhammad Afif Jazimi bin Zamri.
Today we're going to tell you about momentum.
Yeah. So we are going to
Show you how momentum works on your boat.
Why I cannot push you, man?
It's momentum, bro. Relax, bro. I'll tell you how this thing happened.
Okay, go ahead.
Do you know what's the formula of momentum?
Of course, man. I learned at school.
Okay, tell me. What's that?
Momentum equals to S times velocity.
Because of that, you cannot push me.
Why?
Because you're so big and you're small.
Oh, rules what, man?
Relax, bro. Relax, bro. Relax, bro. If you want to push me, you need to increase your velocity. So the momentum that you make is more bigger than before, like what you did before.
So, if I want to push you, I need to take more distance.
Yes.
Push you.
Yes, bro.
If more distance I make, the more velocity I can make. The more I can push you, the more sacrifice. What? Right now.
That's right.
I want to push you, so you need to stay here.
That's right.
I want to push someone, I increase my velocity.
And your distance.
Oh, and my distance.
Because you were so big.
I'm so big.
Yes, bro.
Okay. So thanks a lot for teaching me the momentum flow.
Okay, bro.
So can we be friends?
Okay, bro. My name is Muhammad Islam.
Oh, my name is Muhammad Afif. Sorry. Yeah.
Hello and good evening. I am Wan Kasha. Today I'm gonna show a simple experiment that may include in our topic in Physics 1, that is work done. But for this experiment, it may include on how to find the work done. So I start off with this white box, and as you can see, I already put a string on it. Then I will put the white box at the left side of the corner. Now I'm gonna drag it along the floor. And for the experiment, let's ignore the friction between the horizontal floor and the under surface of the box. Now let's transfer this situation into a diagram. For the white box before, I will represent it with as in the blue box. For the first arrow, that as you can see in the diagram, in the diagram, it will represent as the string and also the direction of the pulling. And let's say the force of the pulling for the string is 50 Newton. Now, for the second echo, it will represent the distance of the box have been pulled by the string. And let's say the distance is 3 meters. And another thing, the angle between the distance of the pulling and the pulling direction of the pulling is 13 degrees. And as I said before, ignore the friction between the horizontal floor and the undersurface of the box. So no friction may imply in this experiment, also in this situation. Now, the simple diagram for the situation is done. Let's find the work done. For the work done, it may include need three values. But for the first one is the force or F, that is 15 Newton. Next is the angle or theta. The angle is 13 degrees. Finally, the distance of the box have traveled, or D, that is 3 meters. To find the work done, we can use one of the equations that have been made available, that is F D cos theta. And as you can see, we can use the equation by replacing the number in the equation, such as like 15 multiplied with 3 multiplied with cos 13. And the final answer for our question here is 129.9 joule. And that is our final answer for how to find the work done for this situation before.
I am who I'm meant to be. Over and out again. My future needed clarity.